Okay, very good. How many of you have made a designed and ordered a printed circuit board? Okay, couple back there. I hope that if we ask that in a month or so, or maybe even a week, there's going to be more than that. A little bit of my background is I am very weak on this type of stuff. I went to a presentation here, I think it was on KiCad, and I came out of there thinking the instructor is just unbelievably brilliant. The program is just, I can't believe how involved it is, and I don't have the foggiest idea where to start. Well, my approach here is going to be to take it very, very simple and to show y'all, and there is you'll have my presentation, you'll have a number of links here, including a link that I based this on. It's kind of like my classes. It's not the best in the world, but it kind of moves you through simply in that. So for a long time, I started doing printed circuit boards a little bit back probably 40 years ago. And back then it was a photographic projector and acid, and some of you know that process or whatever. And then I got out of that, and then it has been very, very expensive. I understand just a few years back, if you're doing prototypes for a corporate deal, it might cost $1,000 or so to crank out a few boards or so. So I'm going to mention a couple of guys I think y'all know, or at least a number of you know them. One is Dale Wheat, which is an amazing guy to me, and he's always saying you need to do this and whatever. And he actually showed off one time with I came up with a 4-foot scrolling Times Square sign, and he next thing I knew, he's got dalewheat.com. He sells this stuff. And you'll see it there. He sells it. If you pay $10, you get the board, all the components that go on it, except the processor, and the headers and so forth, including Brady's board or whatever he put on it. I don't get any payback on that, but that's kind of the way that one goes. So I'll be referencing him a number of times, but he started telling me how easy and cheap it was to build your own board. And of course, with Dale, he's always got these crazy ideas of how simple it is. He's the guy that doesn't like libraries. He likes to write his own device drivers. So, wrote, I didn't bring it in, one of the original Arduino books years back. So he told me about that, and is it really possible to get 5, they call it 100 by 100 millimeter, but I call it 4-inch by 4-inch, 2-layer boards for $2. And I came up with this screen here. It shows on the left portion that option. If any of you, if 2 layers is not enough, apparently you can do 6 or 8 layers for 50 by 50, that's 2-inch by 2-inch, for $2, which is just unbelievable to me. Of course, I can't think enough to do that. So let's see if that's really right. Flex PCBs, if you're into that, don't know anything on that. Oh, the bottom line, I don't know if y'all saw it, was what's the catch? The main goal is to show that anyone can do a class. I'm doing the presentation. This actually comes from a 2-hour class that I have run here at Dallas Makerspace and other locations. And this is one of the boards. I'll show you that I have it set up so that if you look at his video, you look at my stuff, you can very simply come up with a board like this and order it. So what got me really started on that is on the classes, I would have them use a breadboard and put a couple of components on it, run a program, and then tear it down, do something else. And of course, a lot of the guys that came into my class didn't know what a breadboard was, and that kind of complicated it. So when Dale kept telling me that, I designed the board that was on the right, or an earlier version of this one, and I posted, there's a link here that you can check out later. I posted that actually someone started it off with a piece of toast and some components and called it a breadboard. And it was a joke. And about number 6, I said, I don't do breadboards anymore. And I came up with this. And I pointed out that in my class, if you did 6 components and didn't tear it down, that's what you end up on the left. And you really can't tell much about that. On the right-hand side, I've got 9 components on the board, plus 3 that are off the board. If you go to that link and scroll down about 3 of them, you'll see where that is. And I'm going to do kind of my own show and tell here. Um, This is that board, classic on it. You know, you recognize the distance sensor, the Pico W. This is that gyro chip, which I can't call the number of. It has temperature sensors. It has a OLED display here, rheostat, and so forth. So, well, I'll let you hand it, then you can hand it back here a little bit. So, on my first step on that was when I got into using the package I'm going to be showing today. It was kind of like, I can't wait to do this. I can't wait. I found a pattern for a Pico W, and I pulled it down and I started designing the thing. And having not been into it, I was looking at kind of other stuff and realized, whoa, this is for the surface mount, because you can use a Pico as a surface mount. But at that point, I was so into it. You know, we don't think twice if we get a cup of Starbucks or a burger or whatever. So for $3.50, I just ordered that with the wrong setup on it. As time went on, I and this is a more recent, I guess it's maybe that same board, but it's a little simpler. You can see what's going on there. In the process of this particular link and the story that was behind that, Paul Urbanus, I think some of you know, he and Dale I count as two of the most creative, sharp people that I know. Paul responded to me several times, and then he wanted to improve it. And the guy is so polite. He kept saying, "Is it okay if I do whatever?" And I'm saying, "Go for it, go team. You know, it is yours now. I want to encourage you and whatever." And we were talking about doing it as a project and posting it. And finally, last night, I got the results. It started back in, I think, November or whatever, and we were going to have it ready for my little robot teenage club. But then Paul got a funded project, and all of a sudden, he is in that. And he is an incredibly detailed guy. So what he did is came up with another one, and we'll be looking at that. And he did just some incredibly nice things here. And if you know Paul, you can probably relate to this. He called me and said, soldering headers to boards, how does that work for you? And I said, it's a pain. You put it in, I put a little solder on the backside, and then I hold the board and I line it up and I touch it till one is straight, and then I see a yes over here or whatever. Not good enough for Paul. How would you simplify that? If you really, okay, I say a negative over here. How about if you do a jig and you put your things down in a jig? I'll pass this around, and if you want to work it, the axis here, wiggle it like this as you lift this up off of there. Here's a jig where you put the headers down in it, and then you lay the blank board across it. And it is, to me, just absolutely amazing. He sent me a big zip file that has all of the details of his stuff. I got it last night, and I haven't had a chance to look at it. But if you want to do any of this stuff, you can do that. Dale always comes to my classes and is no short on suggestions. So he said, I have to do this instead of jumping into it. So what is the overall process? You come up with a circuit, you design the schematic diagram, probably on paper or whatever, so that you have it right. And then you go into the program, which we will do. And the two big steps of this is going to be designing a schematic program in EasyEDA and then converting that to PCB. The schematic is a logical view. You spread things out so it makes sense. And then on the printed circuit board, especially as you get to more involved ones, you want them laid out so the connections are clear and straightforward and so forth. So you do those, when you do a convert to PCB, you arrange the components, you route the signals, and I tell you, I take a beating from both of those guys because they are purists in it into manually routing. And Dale it just drives him nuts when I show how to auto route. And Paul told me last night, said, I was in your class, and when you did an auto route, my eyes were bleeding. So Any rate, I'm not a professional. I'm a hobbyist. I'm showing you all the simple way of doing this stuff. And if you want to get professional, there's other people around that can show you that. There's a design rule check. You can look at 2D and 3D renders, and then you can order the boards. And hopefully by the end of this session, I'll have you so that you can go home, or maybe during the late part of the presentation, if you get bored, you can design your own circuit and order it right here. The exercises that I do in class are that number one, I just have people pull in a few parts onto a board and then align them a little bit just so they know how to do something like that. If you watch the video and want to simulate that, there's a little bit of problem because finding the exact components is kind of a problem. And one of the ones he's real specific about is not even in the library. So what I did from the standpoint of my classes is I have several stages. For exercise 2, I have the link on this. I'll show you in a minute. What you do is you pull over my copy. Now, I have a link where I share it. What you need to do is you pull it over, and at that point, you can't save it or whatever. And I don't think it's on the slide. But if you do a copy or clone, whichever that way, all of a sudden it's yours, and you can do whatever you want to that. But so the first step that I provide is the board size is set up and the components are there, but they're not placed. Oh, you get to move those around. You might rotate them or whatever, and then you connect the wires up. That's really exercise 2. In a class, I'm always behind going through stuff, so I want to take care of people that are behind on that. When you finish exercise 2, you can move on to exercise 3 with your schematic, or I give you a schematic where the schematic portion is completed on that. And I'll show running a design rule checker and so forth, placing the parts. Thanks for coming. We'll see you later. And then on exercise 4, I show the complete thing, how to go through it. The starting point is EasyEDA, which is put out by JLCPCB, a Chinese outfit. I don't have the link in here, but there's some incredible tours from them on YouTube, just incredible factories of what they do. This is the documentation. Here's a link to the class that I work with. It says to use the Chrome browser. Of course, I tried to use another one, Safari. And one of the first things that I did with a resistor that looked like this, I said rotate, and instead of rotating like this, it rotated like that. And I decided, okay, I need to go back, and you'll see me using Chrome with that. You create an account there, and then you are ready to go. When you set up a project, I kind of like the idea of using a smaller screen, so like 600 by 500. It's about a quarter size from the way it would generally start off. Here are the links that I referred to, and you can pull those down. A couple more links. One of them is that years back, I supported a supercomputer out at the old Mostec, and the big thing out there was running the SPICE simulator. I see that SPICE is alive and well and tied to EasyEDA. So I have a link further on so that you can run your own. If you want to order a circuit, the board that I have, here's the link on it. You can pull it up, improve it, and continue on from there. The module, component module, that the component that you select from the library has possibly 5 positions to that. For it to be anywhere near useful to us, it absolutely has to have the schematic diagram, and then it needs to have the footprint for the printed circuit board. Apart from that, and now where these came from, some of them came from manufacturers, really serious manufacturers, some of them came from hobbyists. What you see is what you get on that, I have found out. On the footprint, as I mentioned earlier, pay attention to through hole versus surface mount, because that's always something. And then on a lot of the models, they have set up so you can do a 2D view and a 3D view, which is kind of interesting. And some of them, and I think a limited number, actually support the SPICE simulation. Main layers of a printed circuit board. This shows up when you lay out the printed circuit board. You'll see my little diagram down here to the low left. And what that is, from the copper, you have the center board, and then you have copper on each side of that. Red signals are on the top side, blue signals are on the bottom side. And then apart from that, there's several other ones. The other layer that is interesting to us is a solder mask. And I have an example on that. So that you'll see as you get to the PCB design, you will see a little table like the one on the left, and you can make things visible or invisible with the eyeball, and you can make it active or inactive by clicking the pencil on the left. I'll go through some of this. So exercise 1 is to place and connect a few random parts on the screen. I show a few examples here. I'll do this in a minute. The bottom part of this is kind of good. On the left, they used to call it commonly library. I don't know where that came from, but last night when I was looking at it, it's now the common library is on the left toolbar. You can choose from there, or there's some other serious libraries that you can choose from. That's one of the areas that I'm going to pretty much say skip here, because I would just really bog down. Even in my 2-hour class, I don't cover it very much. Typically what you do is you find a part over on the left, you click that, you don't drag it, but as you move across, I'll show in a minute, you click the left button and it drops a copy. You slide away. Oh, it's going to place another one. If you click again, it places another one. Or I keep seeing laughter back there. I think you've had experience on CAD programs that do that. But anyway, a right click will kill that. The escape key sometimes looks a little goofy, but if you get in a situation that running traces or dropping components, if you do something and it's a problem, just go ahead and do a right click that terminates that. Control Z is your friend. You can just back it up even quite some number of times. The space bar can be used to rotate. The X key will do a left to right, which you might want to do. Y will do a vertical transition. There will be a couple of little tables that are, that's fine, just hang on to it there. There's 2 sets here, and it looks sometimes like a little bit of overlap on some of these. The one with the kind of almost a Z type thing, I'm having a problem with mouse here. Yeah, here we go. This one, if you can see it, the upper left of wiring tool, that is the one that you use to do a wiring connection. That puts you in the mode for doing that. On the right-hand side, these are used for putting text on the screen or putting graphics on the screen that has nothing to do with a circuit. On the right-hand side, when you're working with things, there's a component table, and there a component properties table. If you wanted to change this from R1 to 3 or something, you can do it a couple of ways. You can go over and click next to the resistor symbol, or you can go over on the table on the right-hand side and change it there. The same is for that 1K. It shows up. If you click the 1K, you can change the text on it, or at the top of component, let you know if you have violated some design rules, which I won't be talking very much about. And when we lay out the PCB screen, you'll have something like the lower left shows up at first. At the upper right is the diagram of the board. The lower right is all of your components. Oh, wait, they're not on the board. Well, they don't put them on the board. They want you to do those. And it's just a left click and slide. You get them where you wanted. And then when you have that, you have a chance to route. It looks like the right side of the screen. 2D view may look something like the one here. The 3D view looks like this. You can actually rotate. It probably may not look exactly like your component. It looks like the generic component that they programmed into the thing. But when that's provided, it is very nice. ready to order on these things. You can just move over into a Gerber, if you're not familiar with, is the name of the file that is very standard for this. It's a CNC type of file. And if you do this, it's not like, oh, I'm starting off with EDA, so I'm wired into using JLCPCB. It's like you get to some midpoint and it says, do you want us to fabricate it, or do you want to write a Gerber file? On the other hand, you use KiCad or something to generate a Gerber file, you can just pull it in and you still get the same thing here, the same special, 4 inches by 4 inches for $2. How am I doing on time? What is it? Okay. Yeah, I decided to just run through these, and I'll go back and do the demo on them. When you finish up with it, as you get ready to order, and one of the things that I do is, smaller boards very often. This is like 1 inch by 2 inches, I believe it was. And I set it up. I told it that I wanted 5 boards. And and it says, okay, oh, the special offer, it's always special, $2. Postage is going to be $1.50. First time I ordered these 6 months ago, they didn't even charge tax on it. They've tightened down on that one now. And what I would do is I would get, I could get a 4 by 4 inch board, or I could get these small ones. And I get all of those just for, I don't know, it doesn't have the total on here, maybe $3.50 or so. Not very bad, but there might be a better way. Let's see if we can find a better way of doing something like that. It's called panelizing. And what that is using your 4 inch by 4 inch to generate more boards on that. And there's a couple of ways it can be done. One is you can have them do it for a couple of more bucks, and you get it and you break it apart. You can, I'll show you in a minute, there's a site called Not Rocket Science. They have a panelizer. And what you do on that, it's a pain, it's not documented, but you go through and that board that he's holding, I get, 9 little circuits on there. How much? $2. And then you break it apart, you take pliers and you break it a little more and you sand it down and you're in good shape. If you want to, you can go that route, but I'd say it is not worth it. Sure.
You said there was a tool. First of all, you said you can analyze it with JLC. And then you said there was a tool that was a thing, but I didn't catch the name.
Oh, okay. The ways that you can do it in the EDA program, you can tell it to panelize there. So it goes into the Gerber file. I've never used that one, and I don't really see a need for that one. There is a tool on, I've got a link on here somewhere. It's coming up. The name of the site is This Is Not Rocket Science, and it looks like something that somebody about as disorganized as me would have come up with, but it's kind of a thing. You'll see the board there that I generated with that. And then the serious way of doing it is to have the JLC PCB do it, and they charge a couple bucks. I'll show you the price on that one. Here is another one. Here is one of the little circuits. I'll let you look through these later. I'll just start it back here. Sure. And by the way, all I know, feel free to ask.
The first one you handed out was what I would call straight panelizing. Everything's square, everything is rectangular. This one has rounded corners and drilled holes.
Yes, I discovered that. Yes.
That's got to cost more.
A little bit more, and we'll look at it in a couple of minutes because I have something on that. And one of the things I have is how many people? I think there's a board for everybody. Everybody grab a board out there, and it's yours. If we run out on that, I will we'll break up another board. Okay, here is the Not Rocket Science. I don't highly recommend this, but to me, it was kind of a fun thing to do. You call that, and then what you do is pull out a Gerber file Then you use not rocket science to position these around and so forth. And do I have? Or did I pass out one of the ones that has little tabs between it?
Yeah.
Okay. And if you actually look at that on the tabs, as it near the board, it's got 3 little laser holes on that to help breaking it or whatever. So this is the not rocket science way of doing it. Cheap, doesn't add anything to the cost on it. If you tell the manufacturer, the fab shop to do it, what you do is on the order page, you select something that's called panel by JLCPCB, and you say how you want it. In this one, I said 2 columns and 4 rows and had it done. Another option that you have is color. It's not that I like green, but if it's green, it is 2 days faster than all the other colors. All the other colors are, there's no extra charge, but it does take 2 days on it.
Brady, quick question.
Sure.
So when you analyze, do you know, let's say you bought boards such that you're 3.5 panels, 3.5 across, 4 inches.
Okay.
Do you just increase the board for 4, and if that costs more, or do you just say, give me a 3x3 and then throw away the rest extra part?
I think, yeah, if it's I think if you go more than the width, I don't think it would let you do that. I'm not really positive on that. By the way, one of the things on this is the shipping on this is real cheap. And if you order 10 boards, all of a sudden, I think it gets into like $10 or so. I think it is some way the government, that means your tax money, subsidizes stuff up to maybe, just hang on to it, I'll get a couple of ounces or some such. But if you, I needed at one point 10 copies of something. I felt like I was cheating or whatever, but I just ordered it and then reordered another one, and saved money on that. But hey, it's legit. That's the way they do things. You guys subsidize my postage on that one.
Take a picture of this. Do you have a problem?
On take of this? Oh, no,
Well,
no,
a little better than I've got in my hand.
no, feel free. So anyway, this is how it gets panelized there. Here are some orders. In this case, this board here is 5 pieces, and it would be, I told it 2 columns, 4 rows, which meant that I would have 8 or 40 boards total. The total on that was like $9 or so, or under $10. And, a quarter a piece, that's not bad at all. Here is my not rocket science board. The cost of the merchandise on that was, I guess $470. I'm not sure where the extra cost was. Maybe there was a bit of an extra cost there, but at any rate, I see that as just real cheap. The bottom one is kind of a classic thing. It's 5 boards, and it is $350 total. Here's another one that is, but in this case, and this is where I could have told them, round corners and so forth, and I wouldn't even need to break anything apart. But it's showing 30 pieces at $5.70, which is, I think, pretty reasonable for something like this, unless you're into mass production. So anyway, I did a schematic of it, which is kind of the background there. And I don't know, I can read schematics, but I'm not good at designing them. And then Paul did one that showed really the way a professional would do it. Here is his board that I just picked those up last night. And here is a link. The file that he sent me has a lot of stuff about his background, about how he designed all this stuff. I haven't even had a chance to look at it in detail, but I did share it out. He was going to put it, or he is going to put it, I think, on GitHub. I said, can I share it with this group? And he said, sure. So if you have questions, I am not real familiar with that, but he is, I think, on, he called it Discord for DPRG. Do y'all use Discord? Or, okay.
Yeah.
So you can hit him with questions on that.
About that. How did he make those, the jig, the casings that the connectors fit into? Like, is that 3D printed or what?
It's 3D printed, yes.
Okay.
And the STL file is there if you want to do it. And it is, if you get him started on it, he had a lot of detailed issues and the width of the printing and so forth, but he did an incredible job.
Can you go back a slide too?
Sure.
I want to see the board. Okay. So this is called his Easy,
Easy Lab?
Easy Lab. Oh, I see.
Yeah, over there.
Okay. So what is he using on the vertical boards? What are those generally?
No, which now?
Are those sensor boards going, the ones that are going like this? Oh, here's his motherboard, and then he has boards sticking up.
Oh, those are based on headers.
What?
He just has female header, typically female headers there, and then the other boards just plug into that. And
He's using some little sensor boards and stuff.
how's that?
Looks like he's using little sensor boards, like infrared sensors or whatever.
Yeah.
Sensor.
Let me see, where are those boards that we passed? Are they? Oh, okay, wonderful.
Okay, is this one?
Yeah.
So that one?
And as a matter of fact, I think I have one more here. Oh, I was going to pass this around. This is his jig. Did I pass that? Okay. So any rate, it's all based on like female headers. Does that answer your question?
I'm doing something similar, not for this purpose. I'm doing robot modules.
Yeah.
And this is my use that I like.
Yeah. So any rate, this, from my standpoint of having class, of course, when I did this, all of a sudden, instead of people having to figure where to plug in the breadboard, it created another problem for me. Instead of the newbies working 30 minutes on finding wherever, they do that in 2 minutes. I had to add some more stuff to that. And one of the things that he has in that big zip file is he took the programs that I use on my class, which is a bunch of little Python programs for various sensors or whatever, cleaned up a bunch of them, and they are out there. So you can generally figure out from the name what it goes with. And on the board, it indicates what kind of sensors get plugged into that. And oh yeah, he has a spreadsheet on those. It says even where you can order them. So it was just incredible. Okay, do I have another, how long can I go? 10? As long, okay, guys. This is not necessarily a part of it, but I ran across using the EasyEDA to do a simulation. And in effect, I think a lot of you might be familiar with a 555 chip that is used as an oscillator. And in effect, what it does is there's a little capacitor, the capacitor over on the lower left. What the circuit does, it will let that charge up until it gets to 2/3 of the supply voltage. Let's say supply voltage is 6 volts. It charges up to 4 volts, and then it shorts it through a resistor to go back down to 1/3 of the supply voltage, which is like 2 volts. And it's just on and off and on and off. And it is the interesting thing. I remember when it hit the hobby market, it was like, wow, everybody had to have one. And Wikipedia said 1 billion of them were sold like 5 years ago, I think within a year. So it is a popular circuit on that. What happens when you simulate that? Well, you get something kind of like the diagram here. And at 0 time, it starts charging up, and it charges up to like 4 volts. And then another second later, it is down to 2 volts and up to 4 and down and back and forth. So it is an incredible, powerful simulator. Let me switch now and do some a demonstration on this. And what you do when you log into here, I'm having a problem with my mouse, so we'll just see what happens here. Let's do a file new, and we will tell it a new project. And the name of it is, I'll give it a bunch of A's, always do that. And we come up with a board here, and what I want to do is make this larger. And I want to change, I'm clicking the rim up here, and when I click with my mouse not working, I'm kind of handicapped here, but let me just call this up and see what we can do here. What I want to do is place just a few things on there, kind of random stuff, and then run it through the whole process. Over here is, this is the project that I'm working on. As you get several of them, you click that and it shows them out here. The design manager, don't really pay much attention to that. The common library is some parts, and we'll pull some parts from this. There are a couple of other libraries from the commercial libraries that you can use where you go through and you find those. Dale Wheat is really big on that from the standpoint of DaleWheat.com. He has boards that he builds and sells, and he will now has them, he finds the board that is available, and he orders the boards where they have been populated with all the surface mount devices. The through-hole stuff, he does the soldering himself on that because it gets more expensive, but that's worked out well for him. Let's see what happens if we choose a resistor, and I move out here, and I drop it, and I'll come down, and I drop another copy of it. Now, it's still attached here, so if I do a right-click, that goes away. I will scroll here a little bit. Here's a connector that I used. And I'll move out here, and I will drop the connector there, and I will end that one. So you move those out, and see if I can zoom my view. Every time I do a class here, when I plug that in, it kind of messes things up. So anyway, I think you can see on this. So anyway, here is a schematic diagram screen that has a few things on it. Let's say I want to do some connections here. And I will say that I want to choose this. And you actually can just touch without choosing the wiring tool. You touch something, it'll make a connection. But I like that because when you do it, you come over here and you'll see that it has a little ball that says, okay, you're connected here. I run over here, how far do I want that to be? I do a single connection on that, a single tap on it. Now, as I move around, I can make the other connection, and it's ready to do some other connection here. If I click here, it lets me run down. I don't know, this is terrible. So at that point, we've done our schematic thing, and what we've done is two types of components, and we have a couple of connections here. I'm just going to run on through here at this point, and I always forget to do it. Command S, Control S to save it. We're ready to move forward here. So what we do is we go up to the Design tab and tell it that I want to convert the schematic to a printed circuit board. And it says, do you want to check the nets? And I will check, yes, I do. And what it does, it shows us here that I have a couple of nets. And if I click this one, it if I click the nets at the bottom, it says, oh, here is this net, here is this other net, and this triangle says, yeah, I don't like this very much. Well, the reason it doesn't like those is I have some things out here that are disconnected. And one of the ones is like DC1 is our DC3. Yeah, DC3 is a problem. It is disconnected. If I wanted to fix that, I can go up here into my wiring tool and I choose the X, and I say, oh, that is a non-connect. So I go here, click it, the X stays there, and that says, I'm not trying to use this. I know it is there. So let's do another design, convert to PCB, and we will check this out now. And it doesn't flag an error on that one. That's one of those things. Feel free not to use it. I generally don't, but that's what the design rule checking would do. So let me do again, convert to schematic to PCB. Don't worry about the rules. Let's go charging forward. Okay, at that point, I had not done a save. There you go. So we will do a design convert. Is how big our board should be. Well, I'm going to say I want it bigger. I want it like 50 millimeters by 50 millimeters. And what that does then is it actually causes these to be inside our box here. And what we have is a resistor and then another resistor here. And if I move these around, those are called RAT lines, RAT lines. And that's saying you're supposed to connect these things together, dummy. And then if I move this one around, there are not any there. But let's say if I wanted to manually route, which I do a miserable job on here, I go over and in the PCB tools, I choose again the connection thing here. And I move out here and I say, I want to connect here and I want it to come out maybe to here. And I'll make this a little more complicated than it necessarily has to be. I'll go to here and then I will move down here and close off the connection. And that gets it. Now there's several things I'm skipping. There's a way in here, and I think it's probably over to the left. You choose your routing width. It is now a 1/4 millimeter, which is real thin. I just, for my first boards, I didn't do better. I did that and it worked, but you probably want to pay attention to that. So any rate, let me to move through to a conclusion here. Tell it that from here, okay, I'm happy with that. I want to have a board made on that. So I tell it to, I'll tell you what, I haven't fully routed that. I wanted to show you this. Let's say I unroute. That clears everything back. Dale and Paul are not around, so I'm going to hit auto route. And I consider it to be magic. And I say run, and it takes a couple of seconds to do. It runs. It said I attempted 6 nodes, I guess. It completed 6 of them. It failed 0 of them. And vias is something that professionals don't like to use. That's where on the top layer, then you drill a hole down the bottom or whatever, and they pride themselves by minimizing the number of vias. Well, on this one, it was easy to come up with 0. And for my boards, I have had, I thought, a reasonable number for a hobbyist to do. So we give that an okay. And so it is now routed. We have everything on there that we want to do. We haven't put any text on it, but let's just tell it that we want to go into fabrication. I just always think of it as pick the one that says Gerber and always save. Control S, Command S. And I go back to fabrication and choose that. And do I want to do a design rule check? No, let's just go for it. And I say, do this. And they say, oh, okay, here's a 2D view of what your board might look at like. It's going to be green. Do I want green or do I want to spend a couple extra days and get it in red? Maybe I want to go with red. At that point, I am ready to order this. So, what's that?
I said, pink.
Yeah. Do we want? I greatly appreciate women being in classes and whatever. And actually, a female PhD professor at UTD was in one of my classes and said on the same thing and said, I want you to come up to UTD and do one of your classes for kind of an informal group. And I did that. And I mentioned on that, and UTA in the mid-60s, physics and math classes, I'd have a woman or two. We got to engineering classes, and it was a 0. And it was so nice. She is running a organization of supporting women engineers at UTD, trying to go nationwide on that. So I always support that. I can't go pink. What do you want? Huh? Yeah, let's just do, well,
What's the other girl color?
hmm?
Purple.
Purple? Okay, there we go. We'll go with purple on that. And we will tell it, it doesn't change here, but we tell it that we want to order it. And do we want to generate it finished? Okay. I think I give this a no because I think that's if I do other special stuff.
And Brady, are you going to show holes and rounded corners?
In what? Oh, I can, sure. Give it an okay here. Yeah.
How many times have you done a class and you get home and there's an order of boards waiting for you?
How's that?
How many times have you taught a class and when you get home, there's a bunch of boards waiting for you because you did the wrong time?
Oh. I'll show you a trick on that one. How to not cost me any money on that. And I'm not a robot and a sign in. Okay, so I'm in, and we come up with this screen. What's on this screen that's interesting? There's a lot of special. Now, this is not a hobby site. This is a heavy-duty commercial site. A number of ways we can have it fabricated. We want a copper core because of heat or whatever, or a million other options that I don't understand. Here is the dimensions that we're giving it. Here is the number of boards that we are ordering, and it is 50 by 50. And tell you what, let me do here. Let me say that, well, first off, here's the cost on it. The cost on it is like $2, and I'm going to save that to the cart. Oh, somehow, add Gerber file. Somehow I missed that. The only next screen was going to be that it shows how much the postage is. On the postage, you need to look closely at that because what they'll do is they will bill in 3-day shipping instead of 12 or 14-day shipping. And that costs some more bucks, but that's it. Unfortunately, I couldn't come up with that screen because I was going to say, okay, it's all ready for an address and a credit. You have a credit card I could use? No, I tell you. Okay, let me back up a little bit and hit a couple of things here on the, when we are in the schematic.
Yeah, 2 or 3 days was for this end of DHL usually. But it's 2 or 3 days after they start production. Usually there's like, I think, a 2-day or 3-day lead time from the time you place the order to the time you start production. That was like, 5 years ago.
Yeah, what happens when you click that you want to order something, they review it for, they say 10 to 60 minutes. And one of the things that I read, somebody had something that appeared to be a mistake. Guy sent him a message that this looks like a mistake. He responded, no, go with it. And they went with it. But so they passed that stage. And I think for the options that I use, the $2 thing, I think they call that 2 days. Or if it's a non-green color, it is 4 days. Yeah. So yeah, I've been very impressed by that. So a question that I had is the rounding corners and so forth. So here's our schematic. And we say that we want to, by the way, let's say that you have done the schematic that we did, and then we do a PCB, and then you realize you need to make a change for that, maybe after you've placed some parts. What you want to do is you go back to your schematic, you make your changes, and it might be wires, it might be adding parts or deleting parts. And then when you come back, you want to say update, probably say you want to say update PCB. It takes your other one, it makes the changes to that, and it's there to work with. If you do what I'm about to do here, convert it to PCB, it says, okay, you may have one, I don't really care, I will just do a new one. So I'm going to tell it that I want a new one there. I want to do a no, keep going. Oh, okay, here is how big. It looks at these parts and says, we think it should be 24 by 16. But let's say that I want it to be like 50 by 50 is a good number to me. And the options that I have on that, millimeters, I kind of speak millimeters. I don't speak mils at all, but Dale Wheat is really into mils. He's, decades of mils. So you can change that here if you care to. Copper layers too. If anybody does the, 8 layers, let us know. We want to hear about that one. But the board outline is, I typically just do rectangular. And then I discovered that there's a round rectangular. And when I click that, you'll see another option show up here. Okay, it's round rectangular. Now, what kind of radius do I want on that? And I'll make it a little bit extreme for here just to see that. I'll say 10 millimeters, which is pretty extreme. And I will do an apply, and there we have it.
Is that cost anything?
No. So, some of the things that they do, it is just amazing to me.
Make a couple of holes.
How's that?
Make a couple of holes. Mounting holes.
Oh, mounting holes. I would go to here. And then turn this, well, let's see, let's put another one over here somewhere that counts. Here's one that didn't work, so I will delete that. Now, if I click on this, you will see the properties over here. Wait, that's a pad. This is the hole, the one that has kind of the wings on it. So if I choose that, and I come over here and drop one and drop another one, turn that off, go here and select one that is, it says mounting hole at the top, and the diameter on it is 2 millimeters. Well, we want to show something up, so let's say that we want it to be 10 millimeters, just to really see that it works.
Actually, typical, I would do is 3.2 or 2.2.
Yeah. I wanted to get something that shows up a little bit, so I do a tab there.
Will it do a surrounding?
Here we go. I have a 5 millimeter, so you can really see a difference there. What were you asking?
Will they surround it with, I guess you'd use a pad if you wanted to surround it with a pad.
To protect it?
Actually, typically what they'll have in there is you'll actually have a component that is a mounting hole,
Yeah.
and that will have your surround so that you can actually hook it up in your schematic to ground.
Okay. Do you know what it is up here on the toolbar?
For the EDA, it would be in your schematic, where you drop your resistors. They'll oftentimes have a component that is a mounting hole. That acts like a resistor, you actually just drop it into your schematic. And that's what they do. I don't know if EDA does it that way though. That's typically how PCB and the others do it.
Here is one of the boards. Y'all looked at one of the populated boards like this, and I was going to mount a rotary encoder here. And I did put a circle around it because that's how big the knob might be on that. And I just said auto route. So the dumb auto router just ripped through and said, okay, we can run close to that. So look how close these traces are to that hole. I guess just on the front side. Look at that and then pass it on. And that's what your question is. That's what you want to avoid on that. Dale pointed that out to me as, oh, this is terrible. You don't want to run the trace that close. And I said, well, test and prove that if you compress that with a screw on the encoder, it runs like 17% faster. So I'm always giving him some kind of trash like that. But any rate, what you're talking is a very legitimate thing that you need to pay attention to.
That would be, you could control that.
There's a way. I just don't. I don't know how to do that. I think Dale probably told me, but I just don't know offhand.
But if you've auto routed, is it editable after that, or is it always like it's updated?
let's find out. So we'll move this guy up here, and we will say route, auto route, and we will just say run. And it's running, and we say okay. And maybe I don't like this one. So let me see if I can select him and delete him. There he goes. He's deleted. And then I could go.
Can you hit Control Z real quick?
Control Z.
And can you try selecting one of those control points and just dragging it?
One of which points?
If you highlight the line and control points show up.
Oh, okay. I'm with you. Let me turn this guy off, and I'll go out to here. Oh, yeah, you could get into all sorts of trouble with this.
That's a good example. If that was your search, if you want to go that way.
Yeah. So I am showing you the mechanics from a hobby standpoint going in and doing this, and I would encourage y'all to get in and do it and post out on your, is it Discord or however, if you order a board like this, I would greatly encourage you to do it. Let us know how long it took. Are you happy with the results and so forth? And
Or post it to the googlegroups.com. It's a new email server, and let us know how it's going. So either way, I'll update you on emails and Discord servers here a bit.
so if there's no questions, that's all I have. And
Very